Hello and welcome to your video lecture all about elements. So we've talked about elements a little bit when we talked about matter. We went through them, but today we're really going to get deep down into what makes one element different from the other. And like I said, we've already talked about it, so some of this should sound really familiar to you, but we're going to get a little deeper into our knowledge of elements today. This is going to be really important because on Wednesday we're actually going to be classifying some of our different ways that our elements can combine together, so we really need to understand what an element is. Remember, I told you when we started studying them that an element is a pure atom. That means that when I'm talking about the element carbon, I'm only talking about carbon here. I'm not talking about any other element. We're not talking about oxygen or nitrogen. It's just carbon, the element. So there are no other atoms besides carbon atoms when I'm talking about carbon. If I'm talking about, say, manganese, then I'm only talking about manganese. We're not talking about carbon anymore. So it's different, and we're going to kind of distinguish how each element is different from one and what that means as far as reactivity and stuff like that. But anyways, our easy definition here is a substance that cannot be broken down into simpler substances by chemical means. That means it's pure, and it's the smallest it's going to be. An element is composed of atoms that have the same atomic number. That is, that each atom has the same number of protons in its nucleus. That's the distinction here. Protons, or the number of protons that an atom has, distinguishes what element it is. Now, when we learned about the protons, neutrons, and electrons, we learned that the atomic number can also stand for our electrons in our atom. But as we keep studying elements and chemistry a little bit more, you're going to learn that the number of electrons and neutrons in an atom can change. The number of protons will never change. If I have one atom with 5 protons and one atom with 6 protons, I know that they're two different elements because one has 5 and one has 6. I could have an atom with 5 electrons and another one with 5 electrons, but they might not be the same atom. It's those protons that matter. Remember here, the elements are pure substances. That means when I'm talking about an element, like I said at the beginning, it's only one element. So we're going to learn how to read our periodic table boxes again, and this is going to become important, really, really important when we start talking about bonding and chemical equations. So let's get familiar with this. We're going to start with our element name. So that's right there where my cursor finger right there is pointing. So for our element name, this is manganese. Every element has its own unique name. It doesn't change. If I'm talking about manganese in one context, if I talk about manganese again the next day, I'm still talking about the same element. Many elements have names that are very old. Like chemical symbols, which we're going to learn about in a second, many are based on other languages. Chlorine is named after chloros, the Greek word for greenish yellow. New names are approved by the International Committee. So many of our elements sound funky to us, like manganese is probably not a word you use in your everyday vocabulary, and really and truly we don't use many of the element names in our everyday vocabulary either, so we're learning a whole lot of new stuff here, but many of them have old or funny names because they're either in a different language or they were named a really long time ago. So again, our element name is what we call the element. In class, I'm going to assign you a element, which is what the next slide is about. If you would like to do this along, we'll use number 1. So number 1's element name is hydrogen, and I would give you a periodic table and you would find your element on the periodic table in its little box, and you'd be able to tell me that its element's name is hydrogen. Now we're going to move on to the element symbol, which is right here again signified with my giant pointer. Every element is abbreviated using a unique symbol of 1 or 2 letters. The first letter is always capitalized, and if there is a second letter, it is lowercase. This is really important. As we get talking about chemical equations, I need you to understand that when there's a capital letter, it's starting a new element. So if I had Mg, like what's written on the screen right here, and then I had a big O right here, you would know that we're talking about manganese and oxygen. And that lowercase letter is going to stick side by side with that uppercase letter. So this G isn't coding for anything else. It's with the manganese because it's lowercase. Some are based on languages, like Fe is iron, which doesn't really make sense to us in English, but that's because the Latin word is ferrium. So that makes a little bit more sense there. So some of them, like manganese, you can kind of distinguish there. We've got an M and a G in the name. That makes sense. But Fe always trips people up. That's iron. And again, it's because not only English was used to create the periodic table. Actually, English really wasn't used very much at all because these were mostly named a long time ago and by people all over the world who speak different languages. So if we were doing element number 1, we said that hydrogen is the name for it. Hydrogen is element symbol is a capital H, nothing else, just a capital H. Every element has a unique atomic number. We talked about that. Atomic number, again, indicates the number of protons in the nucleus of the atom. Normal atoms are neutral, so it is also the number of electrons. Until we say differently, when you're reading the atomic number, I want you to think that that is the number of protons for sure, and that will always be the case. But we're going to talk about neutral atoms or ones without a charge, and we're going to say that the number of protons equals the number of electrons. So manganese has 12 protons because its atomic number is 12, and because it's neutral or not charged, it has 12 electrons as well. If we go back to our example 1, your example was hydrogen. Hydrogen's symbol is H, and the atomic number of hydrogen is 1. Can you tell me how many protons hydrogen would have then if its atomic number was 1? Hopefully you said that it has just 1 proton. And if the element is neutral, then we would say that it has 1 electron as well. And lastly today we're going to talk about atomic mass. So atomic mass, again, here is indicated by my pointer. The atomic mass of manganese is 24.305. Atomic mass is the mass of the protons and the neutrons in an atom. Remember, electrons are really small, so they don't add mass to our system. That's also the reason why they rotate around the atom or the nucleus, and why the protons and the neutrons are congregated or squished in the middle. The mass is a decimal because it's an average of the isotopes, which are the elements that have more or less neutrons. So we don't need to talk about isotopes for the purposes of 8th grade science, but it's something you'll hear again. Isotopes happen when we have a different number of neutrons in the nucleus of our atom. So normally we would think that the atomic number, this 12 right here, indicates the number of protons, which we said is always the case. So there are always 12 protons. You could also say if it's neutral, then the manganese here has 12 electrons. And normally we would assume that it also has 12 neutrons as well. But atoms can lose or gain neutrons depending on the environment. We say that when our elements or atoms gain or lose neutrons, we call them isotopes. They are the same element, they just have or do not have as many neutrons as a neutral atom. Well, they'd always be neutral, as a normal atom. So maybe it would have 11 neutrons instead of 12, or maybe it'd have 13 neutrons instead of 12. You try. So what is the atomic mass of hydrogen? If we were looking at a periodic table, the atomic mass of hydrogen would be about 2 point something, because we generally have 1 proton, 1 electron, and 1 neutron in our hydrogen atom. So 1 plus 1 equals 2, and then we've got a little bit of wiggle room. So it would be about 2. That's it. So you're going to turn these notes into Canvas. Tomorrow we're going to be doing an assignment called Get to Know Your Elements, and I will perhaps introduce that to you right now. You can't do it just yet, but I'll introduce it to you. Let's get where we need to go. Remember to turn your notes into Canvas. I'm going to show you how to do tomorrow's assignment as well, so we can get that done with as well. So your notes are going to go right here to element notes. Get to know you. Your element is tomorrow's assignment. Today you're going to be researching the different elements on the periodic table. If you're in person, you're going to complete the activity in your notebook. And if you're virtual, please use this copy right here. It's right here. We're going to make a copy. So here's this. It's pretty long, but I know you can do it. So get to know your elements. which elements are magnetic. It's got some general questions about elements right here, and some continued right here. And then the second page, which I'm sorry, it looks a little funky, starts right here. You're going to use this key right here to fill in the missing information on the squares below. So NE right here, you'll learn, stands for neon. So I would type in neon. I would say the atomic number right here, which is 10. If you had a periodic table, you know it. Element name is neon, so I would type that. And then the use you would find on the website. You do not need to put a picture in. I think that would be too much. But you're going to use this website to help you fill in the information. Ta-da! So you're going to use these different links to help you fill in the information, like this right here. So this would help you fill in the information, like if we go neon right here, it's used in advertising signs, and then it'll help you answer the top questions right here as well. All right, good luck, guys. Have a fantastic day. If you have questions, email me. If you have questions, whether that be on the notes or on the worksheet. Have a great day.